Hello dear students, good morning. Welcome back to the chemistry class. In the previous session we have discussed about the concept of osmosis and osmotic pressure and how to determine the molar mass from this colligative property. We have also given the formula. So in this class we will solve the numerical. Before going to solve the numericals, let us define a few points that is regarding the biological significance of osmosis. In case of plants and animals, we come across with these phenomena. For example, absorption of water from the soil by the roots is an example of osmosis. When the wilted flower, when it is placed in water, which revives, is an example of osmosis. So here in this case what happens? The solvent molecules which moves into the cells and which undergo, or see, when an egg is placed in water and in the salt solution, in both the cases the process is different. In one case, suppose I am here, three beakers are there. In first beaker I have taken the water, second beaker and third beaker. First, second, third. So it contains water, it is empty, and it contains a salt solution. Now place one egg in each three beakers. So in first case, I have placed an egg in all these cases. Same size egg. So in case of water, the concentration of water is more, and hence these water molecules which enter into the egg, as a result the size of egg increases. So in this case it is a normal egg, whereas in case of salt solution, the liquid, the water molecules which comes out of the egg and the size decreases. So in some case, when water enter into the cells, its size increases, it swells, whereas in other case it decreases, size decreases means it undergoing shrink. So this is because of the process of osmosis, we'll come to know. Already we know that. Now, in this process, in one case when water molecules which enter into the cell, and in the second case the water molecules which comes out of the cell, so here hemolysis and plasmolysis. So this is plasmolysis, whereas the second one is, here it is hemolysis. The process in which the water molecule enter into the cells resulting in the swelling or rupture of the cell is known as hemolysis, whereas plasmolysis is a process in which the water molecules which comes out of the cell resulting in the shrinking of the cell, this process is called as plasmolysis. Then depending upon the osmotic pressure of the solutions, as we know that different liquids have different vapor pressure. When it having the different vapor pressure, obviously its osmotic pressure will be different. For example, if suppose a liquid A and B, a concept questions for you, A and B, two liquids are there. So in these two liquids, liquid A, its vapor pressure is 100, assume that its vapor pressure is 40. In one case the vapor pressure is 100, in the second case the vapor pressure is 40. Now you decide yourself which liquids which having higher osmotic pressure and why. Which liquids which having higher osmotic pressure and why. Take a concept questions. Now come back. So here one process is hemolysis and second process is plasmolysis. Now, depending upon the osmotic pressure, we are defining three terms. One is isotonic solution, isotonic solution, hypertonic solution, hypertonic solution, and hypotonic solution, hypotonic solution. Let us consider one example, RBC cells, RB, red blood cell. So RBC, red blood cell, if it is considered. So the liquid, the fluid, cells are, this is isotonic with 0.91% NaCl solution. NaCl solution. 0.91% NaCl solution. That means the liquid inside the RBC and this solutions will have the same osmotic pressure. So here we can define that isotonic solutions means the solutions which having same osmotic pressure pi 1 is equals to pi 2, then it is called isotonic solution, where pi is nothing but what? It represents osmotic pressure. The solutions which having the same osmotic pressure are called as isotonic solution. If it do not have the same osmotic pressure, then it may be hypo or hyper. If less, hypo; if more, hypertonic solution. For example, so if the osmotic pressure is same, so in this case this is first one, that is isotonic solution. Now if this RBC cell and the second one, if the concentration is less than 9.91% of NaCl, if the solution is less than this concentration, what happens? Whether RBC, the red blood cells which undergoing swells or shrink, that means whether it undergoing hemolysis or plasmolysis, whether the liquid, the solvent molecules which comes out of the cells or which enter into the cell, concentration is less than 0.91. Concentration is less means water molecules is more. When water molecules is more, definitely the water molecules which enter into the cell, because outside the cell the water concentration is more. So therefore the RBC which rupture, which swells and which may burst when the concentration is less than 0.91% of NaCl. Suppose if the concentration is greater than 0.91% of NaCl solution, if it is more than this, then definitely it undergoing plasmolysis, the RBC, the cells which shrink. So here in the first case we can say this is isotonic, RBC is isotonic with the solution, whereas the second one, so here the concentration is less. When its concentration is less than this, its concentration is less, so its concentration is more than this. When concentration is more, definitely osmotic pressure will be more. So in this case osmotic pressure, let us call this as pi 1 and this is pi 2. So in first case pi 1 is equals to pi 2, therefore these two are isotonic with each other. Second case, its concentration is less. Osmotic pressure pi is directly proportional to molar concentration. Concentration increases, osmotic pressure increases. Among these two, its concentration is more, so its osmotic pressure is more. So when pi 1 is greater than pi 2, then it is called hypertonic solution. RBC is hypertonic with this solution. Or else I can say NaCl solution is hypotonic with RBC. With respect to RBC, if I am talking, this solution less than 0.91% NaCl solution is hypotonic with this, because less than this, hypotonic. Here concentration is more, whereas in the last case pi 1, pi 2, it's pi 2. Osmotic pressure will be more because Concentration is more. When concentration is more, osmotic pressure is more. When osmotic pressure is more, then this is called hypertonic. Hyper, more. Hypertonic. Suppose let us assume that it is 1.5% NaCl. More than this. 1.5% NaCl is hypertonic with RBC. Right? 1.5% NaCl is hypertonic with RBC. 0.91% is isotonic with RBC. Suppose 0.5, that is less, 0.5% NaCl is hypotonic with RBC. So if greater, hypertonic, if less, this is called hypotonic. Pi 1 is isotonic with pi 2. I am considering two solutions, 1 and 2, or you can take A and B, or any two solutions as per your convenience you can choose. I am saying that the first solution is hypertonic because it is greater, or else you can say the second solution is hypotonic with first. In this case, pi 1 is less than pi 2, so therefore pi 1 is hypo, less. Pi 1 is hypotonic with respect to pi 2, or you can say pi 2 is hypertonic with pi 1. A very simple concept. Definition: isotonic solutions, hypertonic and hypotonic solutions. Right? Let us solve some of the numericals on osmotic pressure. Numericals on osmotic pressure. Yes, take the first one. I think I have given the question paper already. In osmosis concept, the first question. 200 ml of an aqueous solution of protein contains 1.26 grams of protein. The osmotic pressure of the solution is 2.57 into 10 power minus 3 bar at 300 Kelvin. Calculate the molar mass of protein. So here I am writing the given data. Read the question. First question. 200 cm cube of aqueous solution of protein. 200 ml of aqueous solution of protein. So in this line, one term is given, 200 ml. That is volume is given. So here 200 ml volume is given. That is 200 cm cube or 200 ml. 200 ml of aqueous solution of protein which contains 1.26 gram of protein. So this solution containing 1.26 gram of a protein. 1.26 gram of protein is present. And for the protein molar mass we don't know. So this is the given mass. So WB is given. It is given mass is known. Molar mass of that protein is don't know, that we need to calculate. Next, the osmotic pressure of the solution is given. So for this solution, the osmotic pressure is 2.57 into 10 to the power minus 3 bar at 300 Kelvin. That is temperature is given. Now, calculate the molar mass of solute. So we have the formula MB is equals to, or simply pi is equals to WRT, or MB is equals to formula MB is equals to WRT by pi V, where V is volume in liter. If it is in ml, then multiplied by 1000. Now WB is given, that is 1.26. R value, it is universal constant. R value is, so R value is 8.314, 0.0831, 0.0821 and just 2 calories. If the unit is calorie, its value is 2. If unit is atmosphere, then we need to choose this. If unit is bar, then this one. If joules, 8.314. The osmotic pressure is given in terms of bar, therefore the R value is 0.0831 831 into temperature 300 into 1000 divided by pi value is given 2.57 into 10 power minus 3 into volume, that is 200. You can simplify this and write the answer. 1.26 into 83 into 1.5 divided by this. So the final answer is, do the calculations and verify the answer. So here they have given the answer 61039 grams per mole, or we can write 61.04 kg per mole. 61 kg is the molar mass of this protein. Molar mass of protein. How much? So that is 61 kg. Now, second question. If 1.71 gram of a sugar solution, if 1.71 gram of sugar is dissolved in 500 ml of solution, 1.71 gram of a sugar whose molar mass is 342, it is given, MB is 342, it is given, is dissolved in 500 ml solution, at 300 Kelvin. Find the osmotic pressure of a solution. The question is, calculate the osmotic pressure of a solution prepared by dissolving 1.71 gram of sucrose or sugar in 500 ml of solution at 300 Kelvin. So this is the question. So I want to calculate pi. So formula, pi is equals to WRT by M into V. So given mass, molar mass, volume, temperature, R. Now pi is equal to, substitute and simplify, 1.71 R value 0.083. If you are using 83, the unit is bar. If you are using 82, unit is atmosphere. If 8.314, unit is joules. If R value is 2, unit is calorie. So let us use 0.082 atmosphere, standard unit, or we can use bar, standard unit of pressure, 0.083 into temperature is 300 MB. Molar mass is given 342 and volume is 500 ml. It is ml. Let us convert in terms of liter. RL, liter convert madakade em madaku, divide by 1000. So 500 by 1000, 1 by 2, 0.5. So you can write 0.5, RL is 500 divided by 1000. That is multiplied by 1000. So 1s are 2. So further simplifications. This further simplification which gives the answer. The final answer is, so 300, 100 into this 171, 171 1s, it is 2s, 1 by 2, 2 to get cancelled, 2 to cancel. So 0.083 into 3, and that is 0.249, right? 0.249 bar. The osmotic pressure of the solution is 0.249 bar. Next question. Calculate the osmotic pressure of the solution prepared by. So the next question is, calculate the osmotic pressure of the solution, and that solution is prepared by mixing of 100 ml of 3.4% urea solution, and 100 ml of 1.6% cane sugar solution. So here I have taken 3.4% of urea solution and 1.6% of cane sugar solution, and both 100 ml are mixed. Then what will be the osmotic pressure of that resultant solution? So I want to calculate the resultant solution. So you can do this in two ways. Number one, calculate the osmotic pressure of this solution and second solution separately and then add the values. Or else you can use the direct formula. As we know that the total osmotic pressure is equals to pi 1 plus pi 2. So you have the formula of pi, that is osmotic pressure. Pi is equals to nRT or CRT, that is concentration, into RT by V. So we have this formula, pi is equals to CRT by pi is equal to CRT, where C is concentration. Concentration is nothing but that is molarity. So what is the molarity of this solution? First you can calculate the molarity of this solution. Now the total volume becomes 200 because I am mixing this solution. So total volume will be 200. So now just you can write this N, that is C means number of moles of solute divided by volume of solution. N1 by V into RT plus N2 by V into RT. RT and V is common, RT and V is common. Just N1 and N2 values we need to know. So here N1 plus N2 into RT by V. So N1 means given mass by molar mass. N1, the first one, this is the second one. N1 given mass is 3.4% urea, and for urea molar mass is 60 because urea formula NH2CO NH2. So therefore N1 is 3.4 divided by 60 plus N2 is 1.6 divided by 342. R value is 0.083 into T is temperature is given or not? Okay, temperature is given at 293. These two are mixed at a temperature 293 divided by volume is 200 ml. So therefore it is multiplied by 1000. Yes, simplify and write the answer. This is first case. Direct method. Simplify and find the answer. So here the answer is, the final answer is 7.46. Verify the calculation, 7.46. This is first method. What about the second method? Second method is individually you need to calculate the pi values. Individually means how? So given mass, molar mass, volume is known. So for pi 1 that is for urea solution. Pi 1 for urea solution, that is 3.4 divided by 60. N, that is given mass by molar mass, number of moles, divided by volume of solution into R into T. RT. R and T. R value is 0.083 and 293. This is pi 1 value. Pi 1. Whereas the second pi 1, its values comes out to be pi 1 3.460. Its value is, this value is 6.89 bar. Verify the calculation. Second one, for sugar solution, pi 2 is equals to 1.6% is given. Its molar mass is 342, volume is 200 into R value 0.083 and 293 will be temperature. So its values comes out to be 0.57. So therefore total osmotic pressure is equals to pi 1 plus pi 2. It is 6.89 plus 0.57, that is 7.46. Unit is bar because 0.083 we have used. The unit is bar. Either you can use directly or separately you can use. Right. Take one more problem. Next one. 3.6. 36. Okay, 36 gram of glucose is dissolved per liter of a solution. Next problem. 36 gram of glucose is dissolved per liter of a solution. which has a osmotic pressure of 4.98 bar at 300. The question is 36 grams of glucose per liter. It has an osmotic pressure is equals to 4.98 at 4.98 unit is bar at 300 Kelvin temperature. Next, if the osmotic pressure of another solution is 1.52 bar at the same temperature, what will be its concentration? What is its concentration? So here its concentration is given. This is C1. So what will be the concentration of the second solution whose osmotic pressure is this? For the first solution, that is 6 gram of glucose is dissolved in 1 liter. That means concentration, molarity you can calculate, right? 36 gram, given mass, glucose 180, molar mass, volume is given, that is 1 liter. Number of moles per liter, you will get molarity. So C1 is given. It is given, pi 1 is known. So C2 and pi 2. So we have the equation. For example, pi 1 is equals to C1 RT. That is pi is equal to CRT. And the second one is pi 2 is equal to C2 RT. In both the case, RT is common. So let us divide these two solutions. Pi 1 divided by pi 2 is equals to C1 RT divided by C2 RT. RT get cancels. Pi 1 value is 4.98 divided by 1.52 is equals to C1 is nothing but what? Concentration. What is the molarity of C1? C1 molarity is given mass 36 divided by 180 divided by 1000 into 1000. So 36 by 180 whole divided by. Second solution concentration I don't know, just I am writing as C2. Writing as C2. And in this place, first you can write C1 by C2. Simplify. 4.98 into C2 is equals to C1 into 1.52. C1 value is 36 divided by 180, 1.52. So therefore C2 is equals to, therefore C2 concentration is equals to 36 into 1.52 divided by 180 into 4.98. Therefore the concentration of the second solution is 0.061 molar molarity. Yes, right. Now let us solve the remaining problems on the osmotic pressure, and for our upcoming exam VKG2, so up to the osmotic pressure, the main syllabus for the VKG2 is up to this osmotic pressure. There is 4 colligative property. On each colligative property, so approximate same number of questions will be given for our exams. So just practice up to this. In the next session, we will revise the topic for the exam portion, exam syllabus. Okay, thank you.